Now there are two types of error that are associated with hypothesis testing. Type 1 error alpha and type 2 error beta. As you can see in the table shown here, we commit type 1 error alpha, which is also known as significance level, when we wrongly reject the null hypothesis, although it is actually true. Similarly, we commit type 2 error, that is beta, when we fail to reject the null hypothesis, when in reality it is actually false. So if the null hypothesis was false, so ideally we should be rejecting the null hypothesis. But since we have not rejected it, hence we have committed type 2 error. So alpha is the probability of committing a type 1 error, which is also known as significance level. Then beta is the probability of committing type 2 error. And finally, power is the probability that null hypothesis is rejected, given that it is false, which is given by 1 minus beta. Now the next question is, how can we reduce both type 1 and type 2 errors? Or do we have to do a trade-off between them? If yes, then which one is better, or which one will cause less harm? Now in reality, we cannot reduce both the errors simultaneously, because as alpha increases, beta will decrease and vice versa. So we will have to do a trade-off based on the problem at hand. So let's understand this with the help of an example. Suppose in scenario 1, we are doing medical screening of patients for a heart disease, and we are testing our hypothesis as the null hypothesis is there is no disease, and the alternate hypothesis is the person has a disease. So in this case, the type 1 error would be we reject the null hypothesis even though it was true. Hence, we wrongly classified a person having no heart disease as a heart patient. So what are the consequences in this case? Well, he or she may be recommended for further investigation, and later on it will become clear that she has no heart disease. However, if we commit type 2 error in this case, which will mean we fail to reject the null hypothesis when it is false. In other words, we are saying that we classified a person with a heart disease under no disease category. Now this error could be life-threatening. So we can see that in this case, we can afford to commit type 1 error more than type 2 error. So type 1 error is called as false positive and type 2 is called as false negative. We have patient with no disease who is detected with a disease, and he or she may lead to further investigation. And under false negative, a patient having a disease is detected as no disease, which could be a life-threatening situation. Now you can remember this with the analogy of the same example. Suppose you get yourself tested for a heart disease. If you don't have a heart disease, your results would come as negative. But if they come as positive, then it is actually a false positive. It is positive, but it is false at the same time. Similarly, if you have a heart disease, then the result should come as positive. But if they come negative, then it is a false negative. Because results are negative, but at the same time they are false. So I hope this has given some clarity now. Now let's see one more example. There is a murder accused on trial, and a null hypothesis is that he is not guilty, and the alternate hypothesis is that he is guilty. So in this case, if we commit type 1 error, that is, we reject the null hypothesis when it is true, it will mean that an innocent person would be labeled as guilty. And this is a serious injustice. However, on the other hand, type 2 error means if we fail to reject the null hypothesis when it is false, then it means a criminal, a guilty person, is let go by the jury. Now it is also wrong for the society at large, but committing type 1 error in this case is resulting in labeling an innocent person as a murderer. So basically it is all about the trade-off between the type 1 and type 2 error based on the problem at hand, which means the importance of the type 1 and type 2 error will change based on the problem. So that is how you do the trade-off between type 1 and type 2 error.